Okay, I'm going to show you a huge diagram. It's actually not that huge. You do not need to draw this, okay? So do not draw what you're about to see. In fact, the only things that you need to write are the things that we're going to put across the bottom. If you want to do a little sketching, you can actually enhance your notes a little bit, but what you would need for a bare minimum is the stuff that we're going to write across the bottom of this page. The only reason why I'm leaving this page up just for a moment here is because this is really the focus of the quiz that you're going to be taking in probably about 10 minutes or so. And that quiz is going to be mainly about the MEECH, the 6 forms of energy that we have. So not only do you need to know each of the forms of energy, you should know and be able to explain what each of them is. So if you saw something like electrons flowing through a wire, you should know that that would be electrical energy. You must also be able to identify examples of each. Like if I showed you a battery, you should be able to look at that and identify that as chemical energy. If you can do those things, you're pretty much in good shape. Other stuff that's going to be on the quiz that you'll be taking shortly are going to be our energy transformations. So these are the ones we looked at yesterday. We saw a hairdryer, and we saw pretty sure this class got the opportunity to do the hand boiler or the love meter, and we had kind of interesting and awkward conversations about that. Okay, we can test you later today if you're having any issues, see if it was just the day that made it kind of bad. And we never tested the engineering, so we have time left at the end of the day. We'll let you use the love meter and see how you stack up. Okay, here is the energy transformation for today. Please do not draw this unless you are dying to draw this. This does not need to be drawn. But here is an expansion of the hair dryer conversation we were having yesterday. And many of you wanted to have this conversation yesterday. We took a look at a picture of a hair dryer, and I said, you know, give us a simple energy transformation. I think this class came up with a few. You were changing one form into another, and I think you came up with multiple forms in there. So quickly, let's pick this discussion up right here at the giant hair dryer in the front yard of this house. There is a giant hair dryer. Can you tell me a form, or I think this class can give me even more than one form. Can you give me forms of energy that come out of a hair dryer? Not what power, but what comes out. You can give me one or two, that's fine. Yeah, we're thinking break. Heat. Heat is definitely one of them. So in your journal, you do not need to draw this unless you really wanted to, but you should write the word hair dryer. And under it, we should identify one of the forms of energy that's coming out. One of those we had to talk about would be heat.
We already wrote on them.
Oh, I know. I definitely know that. Okay, but now we're going to back it up, and we're going to do this all the way across the page. So this is going to be a big one. We're going to take this one all the way back to its source. Okay, great. So let's continue to go then. What else do we have coming out? I think you identified at least one more. I'm pretty sure. Griffin, what else did you identify coming out?
Mechanical energy.
Yeah, mechanical energy, which was the form of, I think we talked about like wind coming out of a hairdryer or moving air. And did you guys come up with the light thing too? Is that light or electromagnetic coming out?
Electrical. We got electrical.
Well, it'd be electromagnetic.
Yeah, but he wrote electrical yesterday.
Yeah, well, we definitely have some electrical energy going on, okay, because there's electrical inside the mechanism and stuff like that. But there's, and we did talk about light coming out, which could also be electromagnetic, but let's keep it relatively simple and say we turn on the hair dryer, we get heat, and we get wind coming out or moving air, which is mechanical. Great, now we got to back it up. We're going to go and take a look at this cord. This cord goes into the house, plugs into the wall, and then is indirectly goes all the way back to a power plant. Now this house is not like drawn to scale. It's not a huge hair dryer that's plugged in through the window. They don't live right next to an electrical power plant. These are probably miles and miles and miles of wire that take it to a power plant. But let's pretend that, you know, there's the wire going back to the power plant there. What type of energy right here powers the hair dryer? So far we're still talking about relatively simple stuff we talked about yesterday. What type of energy right here is powering the hair dryer? What are you thinking? Yeah.
Electrical.
Yeah, that right there is your electrical. So we got electrical going through the wire. Now we're going to pick it up a little bit.
Oh. You could have told us.
Where we kept it relatively simple. Okay, you'll figure out a way to do this because it can go in any order around your page that you want. That's fine. Where we kept it relatively simple yesterday and just looked like at this closed system of what energy was coming in and what was coming out. We're going to back this one up a little bit further. And if you guys really get it, we're going to back it up pretty much all the way to the beginning. To generate electricity, just like you guys did yesterday, you simply need something to spin. If you can get something spinning, you can generate electricity. And I think that a lot of groups actually got an opportunity to do this using the hand crank thing. This right here is a turbine. You spin it. And when you spin it, you can generate electricity. The exact same thing is true in a electrical power plant. Basically, electrical power plants get things to spin. That's it. Now, they don't use people in there with little tiny cranks like this. And then that powers your hairdryer. That'd be lame, okay? That's not enough energy to power like all of the middle part of New York State. So we need huge turbines. Turbines like the size of this wing of this school. And we need multiple ones. And we need huge amount of energy in order to get them to spin. So let's take a quick peek here. If that turbine is spinning, what type of energy is it? Now don't look for spinning in the means. What is spinning? Rotating. What would that be? It could be a rotating wheel or anything. That's not a really complex question. Which of the means, which of the 6 forms of energy that we're discussing, which one would be rotation or spinning? I love the way that this like trumps people. It shouldn't. That's relatively straightforward. But it's mechanical. Something spinning is just moving. It's moving in a circle. So we're back to mechanical energy in the turbine. So we got our mechanical energy going on right here. Now, some kids are like, well, does that mean that all electrical power plants do is they get things to spin? Yeah, pretty much. They get things to spin. That's it. It's a big spinny thing. The only exception to that would be a solar power plant. They actually can directly generate electricity from electromagnetic waves, and we're going to talk, it's called the photoelectric effect. We're actually going to talk about that a little bit later on. That one's a little bit more complex. Okay? All right, so now for the Smarty Pants, what are they using in this diagram to get that turbine to spin? What is directly being used? It's also the name of our team, which will give you a nice little hint. What are they using to turn that turbine? Same thing on locomotives that you're learning about now in social studies class and stuff like that. What are they using in engineering?
Steam.
Yep, they're using steam. So now, steam moves because it's hot. All right, if you have a teapot on your stove and you turn it on, now does anybody have a teapot in their house that's old school? It's got a whistle on it, and you can actually tell when it's done because it's like, and you can hear that things really loud. Yeah, when steam expands, it moves. Okay, I'm just curious. What about steam allows it to move? What do you know about steam? Which one of the forms of energy would steam have? Oh, this is good. Hello. Hi there. From Miss Kowalski to put on my shelf. Cool. Why, thank you very much.
Jordan!
Oh, did you just, okay, we will name him officially.
No,
This is
I knew
named-
that kid.
Here we have a gift from Miss Kowalski. I think it's supposed to be Charles Darwin. Oh yeah, because there's a little monkey right there. But his name in here will forever be known as Jordan. Thank you. Thank you for naming that for me. So hello, Jordan. You can help us. All right, perfect. What does steam have? What kind of energy does steam have in the means? Steam. If you've ever touched steam, you would know this. Yeah, it hurts. Okay, fairly simple. Yeah, Alexis, what?
Steam.
It's,
heat.
yeah, don't you hate the fact you said that? Don't you just wish you could take that back and pretend it never happened? Yeah, I'm sorry, what'd you say?
Heat.
Heat. Awesome. So steam has heat. So now we're using heat to generate mechanical energy. Sorry, that's a little bit ugly right there. So here we got some heat going on to generate mechanical, which generates electricity, which then makes our hairdryer give off heat and mechanical energy. Finally then, finally, what type of energy are we using to heat the water?
Fire.
Raise your hand, take a look. What type of energy are we using to generate that heat? We're burning the coal, so what kind of energy are we using? The energy is in the coal. Cool, what are you thinking? Because you are pretty happy right now. What?
Chemical.
Yep, that right there is your chemical energy. All right, finally now, before I give you your quiz, I want to bring this up to the next level, the highest possible level I could. This is a very complex energy transformation. We're running your hair dryer and we're kicking that sucker all the way back to the coal we brought out of the ground. But if you take a look up top, we have the energy coming from the sun. Because almost everything that happens on Earth, the energy ultimately comes from the sun. Can anybody give us an explanation of how the energy in coal is actually coming from the sun? Give us a nice quick one there. How does the energy in coal actually come from the sun? Some kids are like, coal comes from the ground and it's far away from the sun. Yes, I know. But how does that energy actually come from the sun? Mr. Daff, what are you thinking?
Like coal is like the remains, like the proud coal is, but it's like they're,
Coal and oil are they're all fossil fuels, so
Yeah.
you're doing a great job.
so
Keep
they're
going.
like from like past generations of things have like died and like just like soil over them, so they have energy from the like eating and stuff from the sun.
Yeah, there you go. Yeah, it's a whole food web thing. Coal eventually, or if you go far enough back, coal, oil, natural gas all come from stuff that was once alive. Dead plant and animal material. Now some of you are like, I hear that, but I'm not getting that. How's like a dead dinosaur like give you coal? Like what's up with that? We can actually see that process kind of happening. Has anybody here ever been to Green Lakes before? Yeah, Green Lakes is kind of out near you. Did you ever gone swimming there?
Yeah.
Okay, well, how about this? Have you ever walked out into the water until you got to the gushy layer? In your toes where it comes up in between your toes and it's cool? Do you know what how many of you know what I'm talking about? And you go and all of a sudden you're like, oh man. Do you ever pick it up and throw it at somebody?
Yes.
Yeah, it's like black. It's like black, black, black. Like kids you actually get in trouble for throwing it. They have fun. They throw it, they're like, dog, dog, and you're like, what are they talking to me? Yeah, kids love to throw that. They love to like, look, I have a beard and a mustache. Look at me. Well, all that stuff right there is all dead stuff. That's what it is. It's mainly dead leaves, but I'm sure dead birds and fish, and it's slowly breaking down, decomposing over time. And it gives you that really, really rich yeah, it makes you think differently about, look, I have a mustache. It's all dead stuff. And it's basically rotting on the bottom. It's breaking down. Microorganisms are eating it. It's turning into that sludge. Now, that right there is like a nice little intermediate step. That stuff eventually, as that lake over time starts to get erosion, starts to fill in, might become a bog or a marsh or a wetland after time. And eventually, like you learned in 6th grade, might get covered over in layers of sedimentary rock. You take that stuff and you put it under a lot of pressure and you put it in a good amount of heat. And you do that for a few or several million years, and then you go back and dig that up, that's your coal or oil. Or it depends on the way that it actually ends up being made. Now that would be a small pocket of oil, but imagine if it's like the Gulf of Mexico, okay? And that whole thing's got like hundreds of feet, and then the whole thing gets covered over, and it's millions of years later. Those are your oil deposits. And that energy eventually is coming from the sun, which makes it pretty cool and straightforward. All right. We have to stop there because you do need to take a quiz. I need you to make sure your journal is back in the bin nice and neatly in the bin it should be in. And I need you to take out something right now. So go ahead and